Okay, good afternoon to you, everyone. And we thank God for sparing our life to see another tutorial, which by the Almighty God's grace, will be my last tutorial for this semester. So God sparing our life. In the subsequent semester, we are going to have tutorials by God's grace. So, pardon me, I've not been doing this in the previous tutorials I've been having, but I felt like there's a need for us to do it. Let me just say a word of prayer. Lord, we thank you for this afternoon. We thank you for we are all here gathered to learn. We pray that as we learn together, you will help us to understand in Jesus' name, and we will not forget in the name of Jesus. And together we will succeed in this course, come out in fine colors in the name of Jesus. Thank you, Almighty God, because we know you have heard us. In Jesus' name we prayed. Okay, so please pardon me. It's very important for us to do so because it's only God that can turn our effort to success. So I don't want to waste any time today because we are going to be spending about 4 hours today. And the plan is that I'm going to cover stiffness matrix method. And if time permits us, we are going to go into flexible matrix method as well. So I believe that those are the most challenging topics in the semester. The other ones we can read together. Professor Taiwo sent that he's going to cover virtually everything in the course. Well, I didn't send him to say that. Professor Taiwo, I hope you are not hungry because I know that it might be very difficult to cover the whole of the course in just a tutorial. So it's going to be stiffness matrix method, and if time permits, flexible matrix method. Can you still hear me?
Yes, sir.
Hello?
We can hear you, Johnson.
Okay. Okay, then. Yes. So we are going to do stiffness matrix method now. And we are going to have just a short break between, and then we move to flexible matrix method. Yes, so in the last tutorial, we did Castigliano's theorem, and we saw how to apply it to beams and also its application to frames. In the first tutorial that Randu took, he taught how to apply it to trusses. So we did beams and frames last week. So today we are going to be going into stiffness matrix method. We are going to consider its application to beams, and we are going to consider its application to trusses. So after that, we take a little break, then we move to flexible matrix method. I might not be able to get to the application to trusses because it's always, we have to do some derivations because those are the things that will help us to be able to appreciate what we are applying when we are applying it. So so if time permits us, I'm going to do all that today. So let us not waste time any further. Let's just get down to business. So we are starting with stiffness matrix method for beams. For beams. So I did a little introduction of stiffness matrix method last week, and I said that what for stiffness matrix method, stiffness matrix method also known as SNM. Well, the stiffness matrix method is a displacement method, while the flexibility matrix method is a force method. It is called a displacement method. Stiffness matrix method is called a displacement method because the displacement is the unknown. But in flexibility matrix, the force is the unknown. So if we have any material from Hooke's law, we know that F is equal to what? KE. Now, so when we are taking it and we are applying it, it is the same thing as P is equal to what? KD. Our P is the force, K is the stiffness, and D is the what? Displacement. So please make sure you pay attention. This topic is very, very, it requires so much attention. So I would like you to pay rapt attention. And if you have any question, please feel free to unmute yourself or put it in the chat box, and Mr. President will read it out to me. So P is equal to KD. So we are applying it first to what? To beams. So if we have a beam member like this, P is equal to KD. If you have a beam member like this, we know that, okay, before we do this, let me just mention this to you also. We know that F force is equal to what? Sigma A. Sigma is stress, A is area. For any elastic member. So sigma is also equal to what? Young's modulus times strain. So if we bring them together, you can say F is equal to E times strain times A. So F equal to E. We also know that E is the same thing as what? E over L. So we have EAE over L. So from this place now, okay, let me use P for F so that you will not be confused with so many Fs. So now, if you compare the fundamental equation of the stiffness matrix method, because it is from this that we move up. This is like the first principle. And then it's from that place that we are building up. So P is equal to KD, P is equal to EAE over L. If you compare both of them, D is the same thing as this, deflection. So we can say that E is equal to what? KD. D is the same thing as E. So that means that the K will be remaining what? EA over L. That is for just an axial member, So let's look at it for a beam now. We are applying it to a beam. Application to beam. So if we have a beam member like this, a beam, the idea of this thickness matrix method is that the first thing you should do is to clamp all the ends. That is, you fix all the ends. So if you fix all the ends, we have this point to be like this, and we have this one to be like this. So let's say length L. So the next thing, the step one is to what? Clamp all ends. So the step two now is to identify the degrees of freedom. So what do we mean by degrees of freedom? It's just simply I'll just draw it out so that you can see. So the first degree of freedom is this. You call it 1. You call this one 2. And then you call this 3. And you call this 4. Now, the meaning of the degree of freedom is that it's supposed to be free to move in the vertical direction and also with a movement. But we know that those are the directions in which it is free to move. It's not moving in the horizontal. So that's why we don't have a 3. You understand? It's moving in it could move in the vertical and it could rotate also. It could move in the vertical and it could rotate. So those are the degrees of freedom. The horizontal is not a part of it. You understand? So now we are looking at this one. So what we want to do now is the step 3. Are we following?
Yes.
Yes.
Hello? Can you see the board clearly?
Yes.
Hello.
You can see the board.
Yes, we can see the board.
Please, I need
Good.
feedback so
It's
that
not
we
clear.
can move fast.
It's
It's
not so
not
clear.
clear.
Oh, it's actually not so clear.
But I can't. Johnson, what's the last word under that? P is equal to EA over L. You said P is equal to K something.
P is equal to KD.
P equals KD, yes. KD. Okay, you can't. That means you can't see the board. Let me try to get closer.
No, the position is good. Maybe it's the network.
I'm using my phone. So please,
Johnson,
don't mind me.
the board is
Can we
good.
get
Is it better now?
Yes.
you just need to
Yeah.
can you kind of read out that
The
last
board is
line of the
good.
first page?
The board
Very
is good.
blurry.
Okay.
After the P
equals
equals
KD.
to E times.
Maybe I'll try to enlarge my writing the more so that you can see.
P is equal to KD. That's what it was.
Okay, but can you just sort out that first page, please?
And that's P equals
Really
KD.
clear.
It's just the fundamental stiffness equation. Yes. Oh, are you just joining? Are you
No.
just joining? We want to move fast today.
But I was not able to see.
Okay. Let me get closer again. Yes. Is it better?
Yes, definitely, yes.
Response, please. So.
It is good.
Oh, good. So let's move on. Oh, a minute. Sorry. Okay. For this. So please pay attention to this derivation because it's really, really going to help you when we are solving the question. So we have this. So we are applying a unit displacement. If it comes like this, unit displacement 1. What will happen to the structure? Fixed. So it was here before. Now it has moved to this place. So this will be the elastic curve. And 1. So we have S11. Then we'll have this one going like this. S21. We have S31, and we have S41. Now, what's the idea of 21, 31, 11, 41? The idea is that at point 1, the unit displacement that we applied, which is in the direction of 1, will have an effect at 1. It will have an effect on the direction 2. That is S2 due to 1. That's the S21. Then it will also have in the direction 3. That is,
exactly.
Okay, this is supposed to be 3. S31. This S41. Because movement is 4. Yes. So it's going to have an effect on the direction 3, X3 due to 1, S4 due to 1. So the next thing is to apply what's that equation called again? That we used to apply in slope deflection method. 2EI over L into brackets. Let's call this A. Let's call this B. 2 theta A plus theta B minus 3 delta L. Now, so if we have this now, don't forget the two ends are fixed. So if they are fixed, that means theta A is equal to 0, theta B is equal to 0, and delta that we are applying, a unit displacement, is what? 1. So that means that our moment will be equal to 2E high over here into bracket 0 plus 0 minus 3 times 1 over L. Now, actually, I have a convention for identifying when the sink moment is positive or when the sink moment is negative. Now, normally, you will tell me that this is supposed to be minus 6E high over L squared. Well, from what, at least that is what you can say, that's obvious. But from this convention, that's the convention I used to use to discover if the sink moment should be positive or negative. If the right support goes down with respect to the left support, my sink is positive. Sink is positive. I believe we all have the convention, so it's not necessary. I don't want to bother you with this, but this is what I use to identify mine. So sink is positive, and if the left support goes up with respect to the right support, that means that what sink is positive. But in the case when I want to clean this place up. So once again, please, you don't need to bother yourself with this. Is what I use to identify the sink moment, if it's positive or negative. So if the right support goes up with respect to the left support, sink is negative, sink moment. And if the left support goes down with respect to the right support, sink is positive. I mean, negative, sorry. So in this case now, we can see that what the left support goes up with respect to the what right support. So this sink is positive. It's supposed to be 60. So it's going to be 6E high over L squared. So please forget the minus. 6E high over L squared. Once again, please use the convention that works for you. This is what works for me. I remember it quite easily. So this is the one that works for you. 6E high over L squared. Now, that M will now be what? Will now be what? S21. Because that is the moment. Is there a question?
Sorry, yes. Can I ask?
So that means
Sorry,
S21
sir.
is equal to 6. There's a question, Abby.
Johnson.
Johnson, can you hear me? Try to unmute yourself.
Oh, who muted me?
But I wanted to mute someone else. I did my mistake. Sorry.
I didn't mute myself in the first place. That means you have been the host that muted me.
I'm sorry for that mistake. I wanted to mute somebody else.
All right.
Entered.
Yes.
Sorry,
So
sir.
Maiwa wanted to ask a question.
Yes. Can you draw like a diagram for the case of this
Maiwa.
sink? Okay, can you hear me?
Yes.
I said, can you like just draw a diagram for the case of this sink is minus when it's negative?
Yes, I can hear you. I can hear you.
Yeah, can you please just like draw a diagram? Yes, for that case, yes.
Okay. When it's negative, it's up here. And that means that this point will be up.
Okay.
Sorry, Johnson, I think your S31 is supposed to
So
go
the right
down
support is
according to
moving up
your
with respect to the left support.
thing.
Or
Johnson, please check your
Say, yeah,
diagram. Is your S3 is
not
please
clear.
check your diagram. Is your S31 supposed to go down according to your
Say, it's
definition
not
of
clear.
zinc being negative? Is your S31 supposed to go down the force? Check your diagram according to your
Hey,
explanation.
Yeah, I can't hear you.
Hi, Johnson.
Your voice is not clear.
Can you hear me now?
Your voice is not clear.
Shay, your voice is clear, but I think the problem is from Johnson's side.
Johnson, I
cannot
think
hear
you
you very well.
I can hear you, but it's sounding
think you
somehow.
like your movements, what you are writing on the board is not consistent with what you are saying. After you probably written something before
Check
we
your
now.
diagram, please.
Oh,
Please, can someone tell Johnson to check his diagram according to what he explained?
Let him join again. I think the communication is not consistent. So once we have him on the same time, I think he's having time lag. Once we have on the same time.
Okay. All right. Thank you. Sorry.
you can't see the board.
I can see the board. I can see the board.
I can see the board now.
All right. So Mayawa was asking me a question. Please, I want us to respond fast so that we can move. Please.
No, it was Shay. Shay was asking a question.
Johnson.
Okay,
Johnson, are you there? Can you hear me?
Yes.
Okay, according to your
I can hear
diagram,
you, yes.
that S31 is going up,
Yes.
and what you explained that the zinc is positive, it's supposed to go down. That's what I wanted to just confirm. That's all. Like your diagram of the S31
Which
and
one
what
is
you
that?
explained. The other side, S31 is going up, and you said for the zinc to be positive, S31 is supposed to go down, according to your explanation.
No, we are calculating this S21. You understand?
Okay.
Are you following me? We are calculating the movement at this point. And at this point, the support moved up, which is this. You understand? The support moved up. So that means this movement will be what? Positive. And similarly, at this point also, the movement will be what? Positive also. But if this one comes down, this support is not moving. Maybe that's what is confusing you. For S41, this support is not moving. This is the one that was moved. So if this support was moved up also, then the movement here will be negative. The movement here also will be negative. Is that clear?
Yes, thank you very much. I appreciate it.
All right. So let's move on. So we have S21 is equal to what? 6E high over L squared. So similarly, S31, which is moment at B will be equal to what? 2E high over L into brackets theta A, Abi, plus 2 theta B minus 3 delta over L. So that becomes our S21 when we substitute the delta inside. So our S41 will be equal to 2E high over L times, just ignore the minus, 3 over L. So that becomes 6E high. Please, you are not supposed to ignore the minus. There is a way you're supposed to do it. But I don't want to bother myself with that way because that's why I just adopted a method that once this is like this, it is positive. Once this is like this, it's positive. So, but then I think some people used to say that if the support goes down, that is -1, and then you put -1 inside. Please, whatever way you can do it, just ensure you are doing the right thing. So S41 is 6E high over L squared. So to obtain S11 is like a vertical force acting right there. We can simply say summation MB is equal to 0. Now, we have been adopting anticlockwise is positive since we started. So that means that minus S11 times L is equal to, and S11 times L plus S21, which is what? 6E high over L squared plus 6E high over L squared is equal to 0. So that means X11 is equal to 12E high over L cubed. I believe that's not so difficult. So we can do the same for S31. I'm going to clean this, please. Can I? The video is available now, so should I?
Yes, you can.
Response. So
Yes, you can. Yes, you can.
S31 plus S11 is equal to 0. There is no load on top of it. So that means that S31 is equal to minus S11, and that will be equal to minus 12E high over L cubed. So that is that. So also, let's apply, we have applied at 1. Now let's apply a unit rotation. I'm going to clean this up now. So apply unit rotation at 2. Unit rotation at 2. So the elastic curve will change. It used to be like this. Once you apply a unit anti-clockwise rotation, when you apply a unit anti-clockwise rotation, it goes like this. So we have the new position to be like this, and this goes like this, and we have an angle like this. So this becomes theta. So we have S22, S12, S32, S42. So do I even need to complete all these things? I can just do 2. Okay, after doing this rotation now, or should I complete everything?
Yes, please.
Hey, I'm feeling like I'm teaching. Okay. Okay, so MA is equal to 2E high over L into bracket 2 theta A plus theta B minus 3 delta over L. So MA will now be, so now since we are applying a unit clockwise rotation here, you can say theta A will be equal to 1, theta B is equal to 0, delta is equal to 0. There is no deflection. So we have MA equals 2E high over L into bracket 2 theta A, that's 2 into bracket 1 plus theta B 0 minus 0. So that becomes F22 is equal to 4E high over L. Note this. So we go to the other side as well. I'm going to clean this up now. S22. So we also do the same for F42. MB is equal to 2E high This MA will become S22 when you put the rotation inside. This MA is just a normal formula, but once you apply the unit rotation, it changes to S22. So MB equals 2E high over L into bracket theta A plus 2 theta B minus 3 delta over L. So that becomes 2E high over L into bracket. What's theta A? Theta A is what? 1. Theta B is 0 minus 0. So we have 2E high over L. So that's S42, right? Let me clean this so that it will not be confusing us. S42 is equal to 3 over L. So that is that. So let's go to S12 and S32. So let me clean this. So we have gotten S22 to be 4E high. We have gotten S42 to be 2E high. So what we need to do, summation MB is equal to what? 0. So that means S12 times L minus S12 times L plus 4E high over L plus 2E high over L is equal to 0. So S12 equals 6E high over L squared. So immediately you can calculate S32. S32 will be equal to minus S12. That's minus 6E high over L squared. So that is that. So let's so the next thing is what? Apply unit displacement at 3. So apply unit displacement at 3. What are we trying to get in all this stress that we are giving ourselves? What we are trying to get is the stiffness matrix. Just like the topic is stiffness matrix method. It is that stiffness matrix that we are going to use to, that we are going to apply to obtain everything that we don't know, like the deflection and the force. So that's why we are trying to generate a stiffness matrix for the whole structure, which we are going to apply it anyway. So you are going to see it. Apply unit displacement at 3. So if we do that, we have a new diagram like this. It was initially here. It moves up. Then it becomes like this. From here to here is 1. So it is due to 3 now. So we have F3, 3, F4, 3, F1 due to 3, and S2 due to 3. So if we do that now, that means we can obtain from the M equals 3 high over L slope deflection equation, MA equals, or less MB equals 2E high over L into brackets 2 theta B, yes, whatever way you arrange it, plus theta A minus 3 delta over L. So that becomes 2E high over L. Now, don't forget what I told you. If the right support goes up with the left to the right, with reference to the left support, it's going to be what? Negative. So we are going to have a negative moment here, minus 3. I drew the diagram, so I believe you can still check that. Minus 3 times 1 over L. So that becomes minus 6E high over L squared. That's S4, 3. S4, 3. So I'm going to clean this off now. S43. So we can calculate S23 as well. MA equals 2E high over L into bracket 2 theta A plus theta B minus 3 delta over L. That becomes 3 high over L into bracket, both ends are fixed. So 0, 0, 0 plus 0 minus 3 over L. So that gives us our S.
This is fading.
Yes. What did you say?
The
It's
marker.
fading.
Yes, yes, sir.
Oh, you can't see the board. You can't see the board clearly anymore.
Let's say we are
sorry.
Thank you.
So, okay, so S22 equals minus 6E high. I believe this is fine.
Very fine, very fine.
Okay. So minus 6E high over L squared. That's S22. Did I say S22 now?
That'll be S23.
Sorry, Jai.
S23.
S23. So this one also should be S. Oh, I'm following this diagram. Sorry, Jai. This diagram is not the one we are using now. This is the diagram we are using. So that was all confused me. S23. S23.
It's fine, sir.
S23. Yes. Okay. So minus 6E high over L squared. So that is done. I'll clean this now. So we apply summation NB is equal to 0. That means S13 times L minus S23 minus 6E high over L squared minus what? 6E high over L squared is equal to 0. So X13 will be equal to minus 12E high over L cubed. This is S13. And you can tell what S33 is going to be immediately. S33 is 12E high over L cubed. 12E high over L cubed. So the next thing is to what? Apply unit rotation at
Rotational point 4.
Yes, apply unit rotation. This thing has started breaking again. What's happening? I hope it's not from my head again.
I can hear you, sir.
We can hear you, Johnson.
All right. Okay, thank you. So we have unit rotation at N4. So that will look like this. So we are rotating it, unit anti-clockwise. Don't forget anti-clockwise rotation at N4. If you rotate it anti-clockwise, it becomes like this. Then we have theta. So also we would have S1 due to 4. We would have S2 due to 4. We would have S4 due to 4. And we have S3 due to 4. So we commence our analysis again. MB is equal to, please. Yeah, so MB equals 2e high over L into brackets 2 theta B plus theta A minus 3 delta over L. So MB is equal to 2e high over L. Theta B is 1, so we have 2 plus theta A is what? 0 minus 0. So MB equals 4E,
S44.
F44 equals 4E high equals 4E high over here. So the same way, don't come and confuse me again. So 4E high over here. Why am I still putting MB here? F44. So 4E high over here. We applied for this one also. S24, MA equals 2E high over here into bracket theta A, 2 theta A, which is 0, plus theta B, which is 1, minus 3 theta L, which is 0. So that becomes 2E high over here equals S24. Good. So that is done. The next thing is now to obtain the vertical forces. So we can say F14 times L minus, we are taking moment about B. So S minus S14 times L plus, this is what, anticlockwise, so plus 4E high over L plus 2E high over L is equal to 0. So S14 equals 6E high over L cubed. So you can tell what S34 will be. S34 is minus 6E high over L cubed. So we are going to organize this whole thing into.
Sorry, it's over L square, not L cube.
I want to clean the board, can I?
It's over L square, Johnson.
Oh, thank you, Jai. Yes, thank you. I've seen it. Thanks. 6EI over L squared. I hope I didn't say over L cubed in the other side. 6EI over L squared.
Yeah,
Can I clean the board? Okay. So to organize everything into a matrix, S equals S11, S12, S13, S14, S21, S22, S23, S24, S31, S32, S33, S44, S41, S42, S43, S44. So let's put it inside. Now, if we put it inside, we can do that by ourselves. So I'll just give us the final formula. S will be equal to E high. This word will be small. I will clean this now. So if you have written this, I just want to clean it again. You don't need to clean it in your home book. So F will be equal to, bring the EI outside because it seems like E high is common for all of them. So we have 12 over L cubed, 6 over L squared. Follow, if I don't get it, if I make a mistake, please tell me. 6 over L squared, 4 over L. Yes, I believe so. So we bring it here. 12 over L cubed, 6 over L squared, 6 over L squared, 4 over L. So this one will, the diagonals will be negative. So that's a way to memorize it. This one that is here is the same as one that is here, but it will negate the other diagonal. This is like the leading diagonal, and negate the elements on the other diagonal. So we also have what's this other one here now? So let me make a reference. Yeah, so we have minus 12 over L cubed, 6 over L squared, 6 over L squared, then 2 over L. In this place, the vertical are the ones are negative, so you can use that to memorize it. And then in this place, this what we have here is the same thing we are going to have here. Yeah, I think that's correct. So what we have here, the same thing we are going to have here, 12 over L cubed, 6 over L squared, 6 over L squared, 2 over L. So that becomes negative the ones on the horizontal. So I believe that will help you to remember it. What we have here is what we have here. Negate the one on the diagonal on this side. What we'll have here is what we'll have here. Negate the one on the vertical, negate the one on the horizontal on this side. Exactly. Hello.
Okay, wait.
So please wait.
Okay. So let's have an example. I'm waiting though, Mr. Mayowa. You can confirm it now from what we did, from the one in the book, from the derivation we did. Can I continue?
Yes. Okay, sir, please.
Am I permitted
So
to
can I ask a
continue?
question? Can I ask a question, sir?
Okay.
Sir Johnson. Hello, sir.
Yes, please ask the
That
question. Yes,
S41.
I can.
Okay. S41. This is over. And can you touch it? Let me
L squared.
The S41, that is 6 over L
I don't
cube.
get.
The S41, the value of S41. The last row.
No, there is no silver.
Yes.
This one here.
And the one, yes. And S21.
It's not L cube.
Yes,
It's
S21.
It's not L cube. It's L.
L square.
This L squared now. It's not L cube. It's L squared.
Okay. Okay. My question now is, okay, if that one is positive.
Exactly.
Yes. Okay. It's clear. Thank you.
No, see, what I put inside this matrix is as a result of the results that we got. So it's not as if I just devised a means to remember it. And that's what I was trying to explain to you. What we have here is what we have here, but you negate the diagonal. What we'll have here, negate the vertical, negate the horizontal. So this result is as a result of what we got while we were doing the derivation. So it's not as if I'm trying to, perform any magic here. I hope that answers your question.
Yes.
Can I proceed?
Thank you. Yes.
Oh, good. Glory to God. So let's move on. So we are going to do an example now. It's a test question, actually. Let me clean the book. Yes. Are we still here?
Yes.
So we are told to solve this. Obtain. Okay. So what we want to do is to solve this completely, obtain the reactions and the necessary things that we want to obtain. To be able to do this, we know that our fundamental equation is P equals KD. But because in trying to solve our equation, okay, I will explain it as we move on. Let me just, so solution. So the step one, clamp we can't call it ends, but I will explain what it is to you now. When we're deriving, please pay attention. Pay attention. It's very easy for you to get confused here. When we're deriving the stiffness matrix for a beam, was there any load applied within?
No.
Response. So
No load, no load.
good. No load. But now we are having load. So what we want to do, we are first going to clamp all the ends. Now, how do you know the ends to clamp? From here to here, you clamp it. You clamp this end also. So how do you know which one to clamp? When there is a change in section, for example, this one is E high, this one is E high. There is a change in section. So you have to clamp this end and this end. Now, when there is a UDL, you clamp the ends of that UDL. You understand? So let me explain that again. When we have a UDL, you clamp the ends of the UDL. When we have the point load, you don't really need to bother yourself about the point load. But when we have a change of section, you clamp the changes in the section. So what that means is that if we have a UDL here, and then we have another UDL here, what will happen is that you have to clamp this place and clamp this place. If we have a change of section, let's say we have this like this, you clamp this place, clamp this place, clamp this place. You understand? So now you clamp the ends of the UDL and you clamp the change of section. So if we do the clamping now, we are going to have something like this.
Johnson. Hello, Johnson.
Yes. Yeah, I can
yes,
hear you.
Yes, can you draw the different pieces? Yes, can you draw the different pieces? Please illustrate it.
The different. Yes, I will, of course. That's what I'm doing now.
I said, please illustrate. Okay.
Can I continue? And that's what I'm doing now.
Yes.
So can I continue?
I said,
okay. So
yes, you can.
The ends of the UDL, you clamp it. We have this. So what's the load, say? 10 kilonewton per meter. So you clamp the ends of the UDL, and when there is a change of section, you clamp the ends of that change of section. So we have 10 kilonewton per meter. Then this one also, you clamp it. You clamp it. So this is 60 kilonewton. This 3 meters. And then we have 6 meters. 50 kilonewton is acting here. Doesn't really matter now. So we have done the clamping now. So the next step is to, now you have to pay attention. When we are deriving the stiffness matrix for a beam, there was no load applied between. You understand? But now we have a load that is applied within it. So what we want to do is to find another structure that can be used to replace this UDL this UDL as it is. So what this means is that I will draw it up now. Look at it very critically. We can say that the one of the UDL that is like this is the same as this is what W kilonewton per meter L. So it's the same thing as having WL over 2, because in our derivation, the loads were applied at the end. So WL over 2, and then a fixed end moment. So this one can be equal to this plus WL over 2.
It's too much.
WL over 2. So what did I I thought as much. But please, I'll just tell you what you need to know about it. You don't need to be doing all this. I just want to use it to explain so that you can understand. I'm going to. What did you say?
Nothing, no. Continue, sir. Continue, sir. Yes, sir.
Okay, so we have a fixed end moment here. If you remember, fixed end moment due to a UDL is WL squared over 12. This one is also WL squared over 12. So we are going to have WL squared over 12, W kilonewton per meter, which is UDL. This one also WL squared over 12. Now look at this. This one here will nullify this one. 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 So we are still having this same UDL there. So if we have that, now why do we now need to do this? Why are we splitting this? The reason we are splitting this is because we want to obtain the moment, the fixed end moment at this point, because we need to apply it in the equation P equals PF plus KD. The PF is our fixed end moment, which are these words. And then, yes, which are this one. So is this one we are going to be drawing out? This one, we are not really showing it. We are going to be drawing this one out. So that means the next step is to express this one as this one. Express this one in the way this one also is going to be. So I'm going to draw it now. I don't know if anyone is confused already.
Very confused.
I'm lost.
Yes, I'm actually confused. Thank you.
Please come again.
Don't worry. Please don't worry about this one. I'll just. Okay. The idea is we want to, because in our derivation there wasn't load in the middle, but now there is a load. So we must find a way to cater for that load. You understand? This W kilonewton per meter. We can say that, okay, if you want to express this one as this, because these ends are fixed now. If they are fixed, that means there should be a moment there. You understand? So the moment due to this load is WL squared over 12, WL squared over 12. But what we want is just a way for us, another way of expressing this UDL. And if we do that, you will see that if we apply WL over 2 at the end, which is, from the reasoning, from the derivation of the stiffness matrix method, we are assuming that what the loads are applied at the end because there was no any intermediate load when we were deriving. So now, if we now assume that and we have WL over 2, then WL over 2 acting up, it has nullified each other that way. And then we have a fixed end moment, WL squared over 12, due to this UDL, WL squared over 12. So this one also, if we look at it, add both of them together, it's still resulting back into this UDL. So why then do we have to split this? The reason we splitted this is because we need this fixed end moment for this equation. So please, don't bother yourself about this one. I don't think it's going to ask us to prove this. Of course, it's not going to. If you check his past test question, it's not going to ask you to prove this. But what you can do is simply, simply what I'm going to show you. So we have P equals PS plus AD. Let's clean that for now, and let's go back to where we are coming from. Please don't worry, you are going to get it. It's not so challenging. You see that you get it. Clamp the hands. So the step 2, express it the way we want to express it. So this one now, what we have to do now is show it like this. The second diagram that I drew, WL over 2. This is 10 kilonewton per meter. This is what? 6 meter. That will be what? Because if you are taking this part alone, you are bringing it out. That means that the load, this load will be creating, the support reaction of this section alone will be half EA, half EA. That is half of this load here, half of this load here. Because this it looks like it's symmetrical about the middle. So 10 kilonewton per meter, 10 times 6, 60. 60 divided by 2. We have 30 kilonewton here, 30 kilonewton here. Considering this one alone, please, are you getting it?
Yes.
Hey, nobody's responding. No.
Yeah, we are. Continue.
Say,
Sir, I'm with you, sir.
Okay.
I'm with you, sir. Thank you.
okay. Oh, all right. So let's move on. 30 kilonewton, 30 kilonewton. This one now, the same thing we are doing. 60 kilonewton. Did someone call me now?
Like I said, we want to respond, but anytime we try to respond,
Okay. So
the
this one we
screen
share it into
cover
two.
the screen.
30.
That's right.
Oh, all right.
Like it
All
will
right.
cover
But
the
you can
screen, so
just
we won't be
pin
able
it
to see
now.
what
You
you're
can
saying.
pin my screen down.
Oh, okay, maybe I need to knock it down. All right, thanks.
And there is a way you can pin my screen so that irrespective of what, okay. So 30 kilonewton, 30 kilonewton. Then there is no load here. So bring that one to half. 0, 0. Don't forget, there should be moment too. So the fixed end moment, WL squared over 12. For this one, I believe you can still remember that one. Fixed end moment due to a UDL is what? WL squared over 12. So WL squared over 12 will be equal to what? 10 times C squared over 12, which is 36 divided by 12. That's 3. We have 30 kilonewton meter. Yes.
Johnson, what about that 30 kilonewton meter that's acting down at the end of that 6 meter span? Are we not using that one for anything?
Oh, no. It's not going to do anything because it's not an intermediate load. It's at the fixed end. So it's not going to do anything for us. But we are still going to use it later. You understand? I will show you where we are going to use it. But let's just follow as we are moving. It's going every force here has its own place. The 2E high has its own place as well. You understand?
Okay.
Are you following?
Yes, thank you.
I think that's a deal. That's a deal theory. Yes. So it's acting at the clamp point. So we are not going to use it. If it was acting in the span, I believe that it will be taken into cognizance, but we are still going to use it anyways. So 30 kilonewton meter, and then from here, 30 kilonewton meter. This also 30 kilonewton meter. For this one also, if you remember, FEM for this one will be what? PL over 8. If the distance between them, because it's acting at the middle, but if it was not acting at the middle, it would be PAB squared over L squared, and then from here to here will be PA squared B over L squared. But because this one is acting at the center, we have PL over 8. So what's our P? 60. 60 times, what is L? 6 meters over 8. So 45. 45. I hope the board is not too rough like this. Don't mind me, I'm using a small board, so, but I believe you can see, Shabi. Please, if you need to write here, you can write so that you'll not be confused. So we have 45 kilonewton meter. 180 over 4, yes, that's 45 kilonewton meter. So this one, everything here is just 0. 0, 0. There is something I didn't do, and I'm sorry about that. This is supposed to be step 3. So the step 2 is the point where you show the degrees of freedom. So we have 1, 2, at the clamp point of 3, 4, 5, 6, 7, 8. So we have indicated
can't really
the
see
degrees
the
of
table is
freedom.
working with.
DOF. The 7 is what?
I said the table is
I didn't hear
working,
you.
so I can't really see.
Oh, all right. Sorry about that.
Thank you.
Can you though? Can you see it now? Yes. So we have
Yes, I got it. Thank you.
7, 8, 5, 6. Yeah. So these are the degrees of freedom. So let's move on now. 45 kilonewton meter. Yes. So we get that. So we need to find a way to aggregate them, bring them together. So we can say that at this end now, the step 4 obtain the known loads and the unknown reaction matrix. The known load matrix and the unknown reaction matrix. So I'm going to clean this side now. Now, please pay attention. So how do you know the loads? The loads are the degrees of freedom. The loads that are being applied are the degrees of freedom, not the intermediate load. Our P equals PF plus KD. This P refers to the loads that are applied at the degrees of freedom that we chose. You understand? So if we go by that, our P will be equal to P1, P2, P3, P4, P5, P6, P7. P1, P2, P3, P4, P5, P6, P7, and P8. Now, this node here, it doesn't only refer, oh yes, it does. So that means we just, the nodes that were applied at the degrees of freedom, that load could refer to a point load, and it could also refer to the movement at that point. Let me come again. Our degrees of freedom, I drew the diagram for us. Maybe I can just indicate it here. 1, 2, 3, 4, 5, 6, 7, 8. So at this point, if there is a load acting here, that would be our P1. But there is no load. That means P1 is equal to 0. So P2, it is fixed. Because it is fixed, P2 will be equal to 0. Now, P3, there is no freedom to move in this one also. So because it is fixed, P3 in the vertical direction will be equal to 0, but we are going to have a P4. In the vertical direction, there is no motion, there is a restraint, but there could be a movement about this point. There could be a rotation, so there could be a movement. So P4 is an unknown. Now P5, there is a load acting at this point, which is what? 30 kilonewton. Don't forget, I didn't touch this one because it's not acting at those points of degrees of freedom. So 30 kilonewton, P5 will be equal to 30. P6, 0. P7, 0. P8 is restrained also, 0. So P4 is the only unknown here. So you can just express it as, please, if you are confused about this, ask me a question. P4, 30, 0, 0, 0. So you mention, you name 1, 2, 3, 4, 5, 6, 7, 8. Is that clear?
Sorry, Johnson, your P4 is unknown because of the roller support at that point, Abi, under. That's what you're saying.
No, because of the roller support. That is why reaction is equal to 0. There is no, there is no any load acting on it. You understand? But there could be a movement here. It's not restrained against movement. If you rotate it, it will rotate now.
Okay, thank you.
Are you sure that's clear? Okay. Any other person before we move on to the next one? Okay, so I'll take the silence as no other person. 1, 2, 3, 4, 5, 6, 7, 8. So also, you need to do the same for the PF. PF now, the PF could be movement, could be load. So how do we know the PF? That's when this one comes into the picture. You understand? So PF now, don't forget, 1 is representing reaction, 2 is representing moment, 3 is representing reaction, 4 is representing moment, like that. So now, if we come to this end now, 30 kilonewton will be what? Representing 1. Is that clear? As a force due to the fixed load, I mean, the fixed end. Do you understand? We are getting the fixed forces. You get what I'm saying? So if you now look at this one now, 1 is acting up. At this point also, 1 is reaction, 2 is moment. At this point also, we have what? A reaction. So that's what? 30 kilonewton. Please, if you get it, tell me you understand.
So please say it again, please.
The silence means we don't understand, are we?
Yes.
Yes, you don't understand.
You don't mind a recap, please.
Okay. So, we brought this one out, talking about it that is due to fixed moment and blah, blah, blah. So we got all this 30 kilonewton meter, 30, and the rest. Now, this is where we want to apply the forces due to the fixed end, EF. So if we have that now, this one is what? 1. This one is 2, representing moment. Abi? Is that clear?
Yes. Continue.
Response to 30 kilonewton. Now, so if you look at this one, so now there is a movement here. So that means this one, this 2 will be what? 30 kilonewton meter. Now, if you now come here, we split it into 2. This one and this one. So just like we used to do when we were doing, I think that was in year 2 or so, you had both of them together to get the value for the reaction at 3. You understand? So to get the reaction, which is 3 now, you say 30 plus 30. That will be 60 kilonewton. So we are going to have our 3 to be 60 here. Now, moment at this point, what is the moment? You sum the moments together. In this course, anticlockwise is usually taken to be positive. So that means for this one now, which is our 2, let me begin to write it. So 1, okay, you are going to be the one to tell me now, so that we know we are getting it. 1, what would be 1 here?
30.
30.
I'm waiting now. Good.
30.
Yes. So what is 2?
60.
Good.
30 kilonewton.
What is 3?
60.
What is 3?
60.
What is 3?
60. 60.
60. Good. So you had 30 plus 30. That's what? 60. Good. So now what is 4?
15.
15 kilonewton.
15. Good. Why is it 15? Why is it 15? Because our anticlockwise is what? Positive. Abi? And this one is what? So since this one is clockwise, it is minus 30. Minus 30 plus 45. That's 15. So we have 15. So the next thing, 5. What is 5?
30.
30.
What is 5? Oh?
30. 30.
Okay, good. We have 30. What is 6?
Minus
45. Minus 45.
5. Good. Minus 45. Why am I only hearing female's voice? Hey, there's me. What's happening to our guys? I'm only hearing, I think.
Johnson, don't be sexist, please. Don't be sexist, please.
It's
We are
only
students of the class.
concerned to make sure everyone is following. Which one is going to be sexy? It's not the best.
Yeah.
No, Sir Johnson, we
How
are
am I
with you.
being sexy, Jamie?
Sir Johnson,
I
continue.
only
We are
I'm
with
want
just
to
kidding,
be
sir. I'm just
someone
kidding, sir.
started it.
you. Don't let us start this conversation.
All right. Yeah.
I'm fine, sir. I'm fine, sir. I'm following.
Okay. I'm coming, please. All right. Minus 45. So next is what? 7. Those ones are 0, 0. 0, 0. So you target 1, 2, 3, 4, 5, 6, 7, 8. So we also need to obtain our D's that we want to get. So I'm going to clean this one now. Are we going to need it? Are we going to need it? No, we are not. So we are obtaining, did I write this step? Step 4, obtain the known load, matrix, unknown reaction, and unknown displacement. And the displacement matrix, not unknown. Displacement matrix. So we have obtained the load, we have obtained the one due to fixed moment. We are obtaining the one due to D now. The displacement matrix is what we are obtaining now. So D, as usual, let's come back to the diagram. 1, will there be a displacement Two, no movement. Because it is fixed. It is fixed against load, it is fixed against moment. Now, this one also, this theory, it is fixed. There is no freedom in let's say the vertical direction. So we have 0. Then there could be movement here. I mean, there could be rotation. If you rotate it, you would have a rotation here, but it is fixed against Abi. It is fixed against load in a minute. All right, I think we're on track. Yes, so it is restrained. The moment also is restrained. Here, only force is restrained, so it will be 0. There won't be deflection. And then only moment is restrained, so there could be a value for it. Then D5, there is no restraint at all. This point is not fixed, Abi. So D5 will be one of our unknowns. This is also, there is no restraint, there is no support, there is no fix. So we are going to have this 6 also. Then D7, that one is going to be 0. D8 is also going to be 0. So we have gotten all these ones. We have P, we have PS, we have D. Now it remains K. This is the point where we are going to apply that big equation. I mean, that big matrix that we got. So I'm going to clean the whole board now so that we can get it for all of them. Can I continue?
Yes, sir.
Any question?
Johnson, why is your
Okay.
D3 0? Why is the D3 0?
Yes. D3. Yes. If you look at the fixed end now, when it is fixed, imagine that you have a fixed end. If you push it up, except they told us that there is a sink, that is when you can say there is a movement. But when it is fixed, if you push it up, it remains the same way it is. There is no deflection. For D1, we have 0. D2 also, it is supported. It is fixed. Movement. You will try to apply a movement at that point because it is fixed I mean, it will not be able to move. So it's not free in that direction. Do you understand? Now, coming to this point now, we have a support there. And this support is restraining vertical motion, because if we try to probably push downwards or push upwards, except they told us that there is a sink or a deflection, what we have here is going to be zero. But for a moment at this point here, now, or a rotation, it's possible that we have that. So that's why D4, we are going to have D4, but for D3, we are not going to have, it's going to be zero, because it's like this support is restraining motion in that vertical direction. Does that answer your question?
Yes, thank you.
All right, very good. So, but this one, there is no restraint at all. No fix, no support. So what do? We are going to calculate them, D5, D6. Now, D7, D8, 6, 0, 0. I hope that is clear to everyone. So now let's go and obtain our stiffness matrix for each of the members. I don't want to clean this one. Let me snap it. Or is anyone writing?
Yes, I'm
Is
writing.
there anyone that's writing?
Yes.
Hello. Oh, good. So Sheyi, you are going to tell me those values. I'm going to clean everything, because there's no way to check those values again. So I want to clean everything. So that is that. The next thing now is to obtain the K for each of the members. Now, K is equal to what? EI. Now, in this case, we have 2 EI. So automatically, we have 2 EI outside also. 2 EI. We are finding, let's call this A, let's call this B, let's call this C, let's call this D. We are finding KAB. Or is it K they used to use? We are using F. K Jari, KAB. So 2 EI, 12 over L cubed. 12 over L cubed. 6 over L squared. 6 over L squared. 4 over L. 12 over L cubed. 6 over L squared. 6 over L squared. 4 over L. Negate diagonal. 12 over L cubed. 6 over L squared. 6 over L squared. If I'm wrong, please tell me. Negate vertical. 12 over L cubed. 6 over L squared. 6 over L squared. 2 over L. Negate horizontal. So that's my way of remembering it. You can devise your own way. So we have KB, 3 high. So that's that. So let's apply the formulas. For KAB now, apply the values. KAB will be equal to, I'm just going to be pressing the calculator. Yes. So 12 over L cubed. Don't forget, you can just put the 2 inside, but so that we'll not be wasting time, get all these things and multiply it by 2. 12 over L cubed. That's 12. 1, 2, 3, 4. 1, 2, 3. 1, 1, 2, 3, 4. So Please, you can be pressing it too, so that if I'm wrong, you tell me. 12 divided by L. L is 6. 6 cubed times 2. 0.111. 6 divided by 6 squared times 2. Please follow so that we will not be wrong. So we have this here, 0.333. We have this here, 4 divided by 6 times 2. 1.333. So that is that. You bring it here, 0.111, 0.333, 0.333, 1.333. What do? Negate diagonal. It will be the same. So if we do likewise here, 12 by L cubed, minus 12 by L cubed, so we have minus 0.111, 6 over L squared, that's 0.333. Now don't forget, I multiplied it by 2. So it's not a thing, it's 6 over L squared that gives 0.333. These two outside here, don't forget when you're doing it. It's very easy to forget these two. So 2 times 6, 12, then minus 6 over L squared, 6 over L squared. So minus 0.333, then 2 over L. 2 divided by 6 times 2. So we have 0.667. Is that correct? Please check if it is correct. This thing is able to nullify everything we are doing. One single mistake like this, you would have gone too far before you know that it is wrong. So is it correct?
Yes, correct.
Please check. Okay. Any other person to confirm for us too? And the reason I'm being careful is because it's able, just one single mistake like this, I mean, it will nullify your whole work. All right, so thank God. So let's move on then. So the next thing to get is what? KBC. KBC is definitely going to be the same thing as what? KAB. Abi, they have the same TE height, they have the same length, so it's going to be the same. But what's going to be different is 5, 6, 7, 8. No, 3, 4, 5, 6, 3, 4, 5, 6. Is that clear to everybody?
No, please.
No.
Yeah? The formula, this is the formula. Abi, imagine that you are applying this same formula for this one. You are still applying the same thing. This formula holds for this section and this section, but it's only going to be different for this section because this one has EI. If the length were different, let's say the length here was 5 meters, that is when this KAB is not going to be the same as what? KBC. Our KAB is a function of what? The section and the length. Now, since the section and the length are the same for the two parts, that means that what? We are still going to be obtaining the same values. Let me come once again. Our KAB is a function of our what? Section and our what? Length. So if the length is the same and the section is the same, that means we are still going to be obtaining the same value for what? Both parts. This is 6 meters, this is 6 meters. 2 EI, 2 EI. But when we come to this place, there is the length is still constant, good, but then the section has changed. So we are going to have a different value. Is that understood now?
Yes.
Yes, thank you.
Yes.
Let's go to 0.111, 0.333. So we are going to have the same thing. So 3, 4, 5, 6. 3, 4, 5, 6. That's the only thing that is different about both of them. Is that clear? So we move to KCD. KCD is just half of any one of them. So let's substitute it. So we have 0.111 divided by 2. That's 0.056. Please check, check so that we'll not be wasting time. Check if it's correct. Follow me. 0.167 minus 0.111 divided by 2. That's minus 0.056. 0.333 divided by 2. That's 0.167. I hope it's not too small to the eyes. So 0.167, 0.667 minus 0.167, 0. Please tell me if I'm wrong. Sorry. I have to be very meticulous when you're doing this thing, so that you don't make mistakes. So we come here, 0.056
Minus 0.167.
0. Okay, minus 0.167, then 0.667. This one will be minus, I mean. You see what I'm saying? There's a mistake already. This is supposed to be minus.
Let's put all the values. We'll tell you the minus later.
So I think we are good now. So yeah, I can't hear you again. It's breaking.
I said, don't worry, just put all the values. We'll tell you where the minus signs are. Your values are correct. You can just check for the minus sign later.
Yes. So minus 0.056, minus 0.167, then 0.167, and 0.333. So we have 5, 6, 7, 8, 5, 6, 7, 8. So the next step is to obtain the global stiffness matrix. This one is local stiffness matrix. Is the one for each of the members. So the next thing is to obtain the global stiffness matrix. The global stiffness matrix is the stiffness matrix for the whole structure. So I'm going to clean this now. But then it's not every time that you get. Okay, yes, it's every time actually. Now, this is the point where you have to be very careful. At this point, our unknown displacements are what? D5, D6, and D4. Abi?
Yes, yes.
So D5, D6, and D4. So in whatever you want to do, you want to ensure that those unknowns are the one that you bring to the front first. The reason is because if you don't do that, that means you would have to obtain the whole of the matrix. Now, it is what? There are about 8 rows and 8 columns. That would be very stressful for you. So what we used to do is that in order to be able to get what we need very fast, you simply bring those unknown that you are those unknown displacements. You simply bring them close to the front so that you will just obtain like 3 columns, 8 rows, instead of obtaining 8 rows, 8 columns, and using only 3 parts of it. So that's first. So what we want to do, as you see now, is that you will bring those unknown that you want to calculate, D5, this is D4, you bring them to the front. So what you can say is we have 5, 6, 4, whatever way you can do for 5, 6, as far as it's the unknowns that you are bringing to the front. 5 is 4, then 1, 2, 3, 7, 8. 5, 6, 4, 1, 2, 3, 7, 8. Do the same thing. Write it up. 5, 6, 4, 1, 2, 3, 7, 8. Does anyone understand what I just explained now?
No.
Does anyone understand?
No.
Did I hear no now?
Yes.
All right. Now, the unknown displacements are what? D4, D5, D6. Now, if we say that we want to begin to obtain the global stiffness matrix for each of them, that means we are going to obtain 8 rows, 8 columns. That is 64 inputs. That's stress. So instead of doing that, why don't we focus on the one that we need? The ones that we need are simply 5, 6, and what? 4. Once we are able to get our D5, D4, D6, we'll be able to obtain whatsoever other thing that we want to do. So that means that all we are trying to do now is simply to obtain the elements in this portion alone, when we leave this one alone. Is that clear now?
Yes.
Is it clear?
Yes. Yes. Thank you.
Okay, glory to God. So let's move on. Now, yes, so K55, 5, 0.111. There is 5 here too, Abi. So 0.111 plus 0.056. That's 0.167. Write it down. Is that clear?
No, please, it's not clear. Oh. Please, it's not clear.
Okay, we are obtaining the global stiffness matrix. This what we obtained here are the what local stiffness matrix. Now, if we have 255, look at this is what 55. The element here is what 0.111. We also have 55 here. You know, we are bringing it together into the global stiffness matrix. That means that all the 55s that we have, we add them together. That will come and enter into the global stiffness matrix. See?
Yes, sir. Yes, sir. I understand, sir. Thank you.
Response. Oh, thank God. So the same thing, 6-5. How many 6-5s do we have here? 6-5. So, okay. Maya, are you still there?
Yes, yes, yes. I'm with you.
Is Maya still there?
Yes, 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 sir.
Yes. So please, you will tell me 6-5. We want to get 6-5. Oh, yeah, please.
I'm not writing it down and I can't see clearly. 6-5. There's 6-5 in K.
You can't see the board clearly.
Yeah, that side, yeah.
I'm getting 2. Is it 2?
Okay.
I got 2.
Your hand is. Okay.
I don't think it should be true. 6-5.
Minus
So
0.
I'm getting minus 0.166.
Yeah.
I'm getting minus
So
0.166.
minus
Sorry.
okay, yeah, good. 6-5 is 0.167 here. Then minus 0. That's minus 0.16, Abby. So we have this space is small. Minus 0.167. So now the same thing, 4-5. I hope you are getting what I'm doing. 4-5. So
yes, sir.
4-5 is 0.33 minus 0.333. There is no any other 4-5 here. So we have minus 0.333. That's correct, Tabi. 4-5. So the next thing is what? 5-6. 5-6 minus 0.333.
Minus 0.166.
0.167. So that's minus 0.166. Please excuse me. Okay, don't worry. Let me just continue. Somebody tried to call me. 5-6, then 6-6. 6-6. 1.333. 6-6. 0.667.
That's
So
2.
that will give us 2.
That's 2. Yes, that's 2, sir.
Good. So 4-6. 4-6. 0.667. Any other 4-6? No. So 0.667. So 5-4. 5-4 is what? Minus 0.333. Any other 5-4? No.
No.
Minus 0.364. 6-4 is what? 0.667. There is no any other 6-4. So 0.667.
Okay.
4-4.
I'm getting 2.666.
Yes.
That's it, I got.
Hello, sir.
Hello, sir. Okay. Let me even come to bring it closer. Is this okay?
Yes.
Yes.
Okay, so let's continue. 0.667, 44, 1.333, and what? Yes, so I'm calling it 2.667, then one.
Okay.
So let's obtain this one. 5.1, 5.1 is what? There is no 5.1, 0. 6.1 is what? There is no 6.1, 0. 4.1 is what? 0.333. I hope you are not confused. Response to.
No. I understand.
Okay. So
0.333.
5.2.
5
Okay.
2. There's no 5 2.
There is no 5.2. 5.2 is 0. 6.2. There is no 6.2 as well. 0.
0.
4.2. There is no 4. No, there is 4.2.
4 to 0.667.
0.667. So 5.3. 5.3 is what? Minus 0.111. 6.3. 0.333. 4.3 is what? 0.333. No, that's 0. Okay, 4.3 0.33343 minus 0.333. So that's what? 0.
57.
57 is what?
0.056.
0.056. Now 67 minus 0.167. 47. That's what? 7. So we have 0. 58 is 58 is 0.667. 0.667.
0.167.
Oh, 0.167. Sorry. 0.167. 68 is what? 0.333.
Yeah.
48. There is no 48, Abby. That's 0. Good. So now, if we had not done this, we would have to get everything. And that would be waste of time because they are useless. Though not totally useless. No. So I want to clean the board. Please check. This thing can affect any of our results too. Can we continue?
Johnson, there's 4-3 now. There's 4-3. Why do you write 0 there?
It cancels out. There's minus 0.333 and there's a positive. So
there are 2 43s. One is negative, one is positive, so it will become 0.
Oh, thank you very much. Thank you, guys.
Yeah, thank you. So let's continue. So now we come to our formula. P equals PF plus KD. So, Sheyi, it's time to fulfill your promise. What is P?
P, we have 0, 0, 0, 3 zeros, 0, 0. Then we have P4. P4.
P4. Okay.
Then we have 30. 30, 3 0.
Okay.
Then we have 0, 0, 0. We have 0, 0, 0.
I think there's an hell. P4 is supposed to be 0. Yes, I'm coming. Yes, P4 is supposed to be 0. Did we write 30 for 5?
Yes, wrote 30 for 5, and we said our P4 is unknown because there can be a moment there.
Supposed to be minus because the force is acting down.
So that's minus 30. Okay, sir.
P5, yes, that's minus 30. Then this one is supposed to be 0.
Please, why? Because he told us that there can be a rotation there because of the fixed whatever.
That's what I want to say. It's supposed to be 0. It's supposed to be 0. P4. Remember that the team supports work now. Moment at the pinned support. Okay, yeah, I know why now. There is no applied moment there. That's why. No moment was applied here. Is that clear to you?
Okay, so because of no moment is applied.
Yes, no moment was applied there. At this point, there was an applied force, which is going down 30 kilonewton. This point too, there is no applied force, there is no applied moment, no applied force, no applied moment, because they are restrained. But this point also, there is no applied moment there. Here, there is an applied force acting down. That's negative, which is minus 30. So that's why it is minus 30. I'm very sorry for that mistake, please. Is that clear to everyone?
No.
Okay, which one is not clear there?
The support at A.
At A.
Yes, that fixed end at A.
50%.
The fixed end at A.
Okay. Okay, so what do you want us to do? There is no movement. Yes, because it is a restraint against motion. At this point, we didn't apply any movement here. No applied movement. Because this one is representing the load matrix, the load that we applied on the structure. This one is representing the one due to the fixed, because it was fixed. So let's say at this end now, at this end, they now told us that they applied a moment of 20 kilonewton meter there. That is when our 2 will now have value. Or let's say at this end.
Okay.
Hey, I'm sorry. This one is low already. This one is low. I will have to use my voice now. I hope you'll be able to hear me.
Can we just take a break?
No, we are going to take. Are we here?
Justin, I want to ask a question.
Can you hear me? Can you hear me?
Yes.
I would have to shout me.
Exactly.
I can't hear what you're saying.
Johnson, we can't hear you.
See, can hear you.
Oh, that's a serious thing.
My Bluetooth receiver is low, so that's why I was trying to use my voice. Okay, let me try to connect it again. Just give me 10 minutes.
Okay, sir. Thank you.
So please, when it's back online, can someone just drop it on the group chat? Thank you.
Can you hear me?
Yes.
Can you hear me?
Yes,
Yes,
I
sir.
can hear
Yes,
you.
sir. Clearly, sir.
We
Praise
can
God.
hear you.
Praise God. Okay.
Hallelujah.
Amen.
Hallelujah.
Please, I'm very sorry for that. My Bluetooth receiver is down, so
Understandable, sir. But we don't-
that's one challenge with that's the Nigerian factor. Our area we don't have, constant power supply here, so that's why it's quite difficult to charge immediately. But I'm currently using my laptop to charge it. So can you hear me?
Yes, we can hear you.
That's fine. Let's move on.
Yes, we can hear you.
We have gotten it. So we bring in PF as well. PF, where should you? You should use the line.
PF 30.
I'm online. I'm online now. What did you ask?
30. 30 again.
Yeah,
Yes.
60.
60. 15. Minus 30. Minus 45. 0, 0.
My dear, write minus 30. I wrote 30 in my own before minus 45.
Me too, it's just 30.
I wrote 30. Who is that? Johnson, I wrote 30 before minus 45. Oh.
It's 30 I wrote.
What's it Chicago? What's it Chicago?
It's 30. It's not minus 30.
Okay, sorry, my bad, my bad.
Johnson, are you there? Pastor Johnson, are you there? Okay,
Yes,
you're there. Thank God.
It's 30. It's not minus. It's not minus. It's 30. Can we continue
Exactly.
now? Okay, so we have
Already.
K. This will be our K. This whole thing here. But then the one that we need now, okay. Yes, we're on track. Yes, I think we are good. So the one we need now is 0.167 minus 0.167 minus 0.333. Hey, my board is small. Is this board showing? Okay. This is what I will do. 0.167 minus 0.167 minus 0. So we are just writing what we have here for our K minus 0.166 to 0.667 minus 0.333, 0.667, 2.667. So now this is what we need. to obtain D5, you know, it will be multiplied by, please write it there. I believe you can do that. There is no space for me to write it. K, D, so do we understand what I'm saying at all?
Can somebody call out the D? Because I wasn't able to write the values that time.
Okay, D values. We are there. We are there. D1 is 0. D2 is 0. D3 is 0.
Sorry.
D4.
Sorry.
Are you with us, Johnson?
Yes, I'm saying something. You know, we are supposed to arrange it in such a way that the ones we are looking for, they are readily available. So instead of arranging it, this are you following?
Do you hear what you
Yes,
said?
Pastor.
Yes, sir.
You
Yes, sir.
can speak up, sir. We are not hearing, sir.
Can you hear me?
Yes,
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 we can hear you
perfect,
now.
perfect.
Yes.
Now, this is wrong. We are supposed to arrange it as 5, 6, 4, 1, 2, 3, 7, 8. Because this one here is arranged as what? 5, 6, 4, 1, 2, 3, 7, 8. Are you following me? So that means our load matrix will also be arranged as 5, 1, 2, 3, 7, 8. Is that clear?
Yes.
Oh, yes, sir. Yes, I understand now, sir. So we have to change something.
Yes.
So
that's
minus 30, then 0, 0, 2.
We will do the same for this one. 5, 6, 4, what? What would that be?
1, 2, 3, 7, 8.
What would it be?
Oh, it should be 30 minus 45, 15.
45.
Yes.
30 minus 45, 15, 30, 30, 60, 0, 0. Minus 45, 15, 30, 30, 60, 0, 0. Oh, I can't hear you.
You can hear me now, Abby.
Yeah, I can hear you now. I can hear you now.
So, you also started with the D5, D6, and D4. D5. Did you hear me?
No, please, I didn't hear you.
You say you have to call it out. You have to call D out in the same order.
So, you know, we are putting it as 5, 6, 4, 1, 2, 3, 7, 8.
Yes, yes. For D, we have D5, D6, D4.
Yes, so what's D5? What's this? What's before?
They don't have a value yet. They are the unknown. That's why it's called displacement method or stiffness matrix method.
Okay.
So D5, D6, D4, and the rest are 0. So let's Let's do that. There's no space for me to write.
Yes, yes.
I've done that, Abby. So we can just, I'm going to clean up this thing.
This thing is mad, though.
Can you hear me?
Yes, you can hear you, yes.
There's only one objective question we have in the exam because this one is already like more than 1 hour I said to solve it. So there's only one objective question. Well,
Sorry, please. That P5, is it meant to be minus 30 or just 30?
Minus 30 because it's acting downward.
Okay, thank you.
Yes, are you getting it now?
No.
Are you getting it?
Yes,
Yes,
yes.
sir, yes.
by social grace of Almighty God.
You get it. Good job, sir.
Bring out all of them. As in, for everything. For PPA and A. We have writing.
So,
Equal to what?
DOT, I beg, off your mic, so I go fit see am, I beg.
Plus, you can just pin it down. Pin my screen down. K 0.167 minus 0.167 minus 0.333 minus 0.166 to 0.667 minus 0.333 0.667 2.667. So let me clean this so that there'll be space. Please be careful now. D5, D6, D4. Do you understand? Do you understand?
Yes. Yes.
Okay. We could have written it here, but there's no space. So, but I've decided to bring these ones out. So once we are able to get this, we'll be able to get our unknown P1, P2, P3, P7, P8. So this one is very simple now. The next thing we do is what? I don't want to claim this because we might need it. So bring them together, minus 60, minus 45, minus 15. Please check if that is correct. Minus 60 plus 45, that's 45, is equal to 0.167 D5 minus 0.167 D6 minus 0.333 D4, then minus 0.166 D5 plus 2 D6.
Please, can you people see the screen? I cannot see the screen. No, I cannot see the screen at all.
Okay, Shay, slide to the other, slide your phone. Then you are going to see Johnson there. Just double tap on it. It's going to pin the screen. That's how I was able to see it.
Thank you.
That's all. So let's move on. Minus 0.333 D5 plus 0.667 D6 plus 2.667 D4. So what's next? Just use calculator to obtain D5, D4, D6. I'm being tempted to clean this. I don't want to clean it. So please, let's obtain D5, D6, D4 with calculator. Don't forget, there is EI. Don't forget, there is EI there. Can we still hear me?
Yes,
Hello?
yes, I can hear you.
Yes, yeah, let's obtain D5, D6, and D4.
No.
Okay, let me even ask you a question. Between writing it down and teaching like this, which one do you think is more okay? Which one do you think is better?
Between writing it down, as in, I don't understand.
Writing what you want to teach, writing everything down and displaying it on the screen, and teaching like it is live.
This one is better.
This is better. This is better.
Okay, because I'm feeling like maybe I'm doing something wrong.
No, this is better. This is good. Thank you.
So let's.
Sorry, please, Johnson. I'm very sorry to take you back. Please, how do you get minus 60?
Okay.
I'm so sorry.
Minus 30, minus 30, minus 60. This one will come here. 0 minus 45.
Okay. Thank you very much.
So let's calculate D5, D6, D4. Can you use the calculator for that one now?
Someone should confirm, sha, but I got my D5 as minus 490.34.
Okay, another person. This 6 is what? Why is this correct?
Sir, what did you say, sir?
I said, is it correct?
Yes.
I mean this one that I circled.
Yes, I've seen it. It's correct.
It's the same, Abby.
Yes, sir, it's the same.
My please, can you call the values out?
Okay. D5 is minus 490.34 over AI. Then D6 is my 4.47. 4.47. D4 is minus 67.96. Minus 67.96.
Minus 67 what?
96.
Okay, that's good.
Okay, so is that good? All right, let's continue. I want to play it. Should I?
No.
My wife, I'm so sorry. Please can you call the values again? Please, sorry.
D5 is minus 490.34 over EI.
Yeah, I'm feeling
D6,
you.
D6 4.47. Then D4 minus 67.96.
Oh no, I'm getting different values. What's this?
Shay, what did you get as your D5?
By D5, I'm getting 302.48. I don't know. Is that all you got?
I'm getting minus. I got minus 435.
Or more. I'm coming now. Do it again, Sha. But I'm getting different values.
Hey, Maiwa,
Sir,
can you read
sir,
out
I'm
your
with you,
values for
sir.
the A? Can you read out the values for the
A,
A,
B,
B,
C,
C,
D.
and D?
It's
Yes.
much, oh. It's much now.
Hold on.
Okay, for the first one, let me
So
just
the first A is 0.1.
0.167. Second one minus 0.167. C is minus
Okay.
0.333. D is minus 16. A is minus 0.166. Huh? For the second one,
Yes.
minus 0.166. B is 2.
Okay.
C is 0.667. D is 45.
Okay.
A is minus 0.333. B is 0.667. C is 2.667.
Okay.
Then D is minus
My
15.
you're right. Thank you.
D is minus 15. Okay.
Can we continue?
My thank you.
Yeah.
Maiwa, thank
You're
you.
welcome.
Thank you. Thank you.
Can we continue?
Wait, I got minus 490.334 for your D5.
Yes, that's correct.
That's it, bro.
So can we continue? Can we continue?
Yes.
Yes, sir. Yes, sir.
D5, D4. So we have gotten this. We are going to use D5, this is D4, to get P1, P2, P3, P7, P8. So I'll clean this
Eh?
one now.
You are still getting something.
Yes, yes. Don't worry, I'll just give us like 10 minutes break. So we'll come back to toss.
Hello, Sir Johnson. What did you say we are looking for?
We are going to get P1, P2, P3, P7, P8.
I thought our P1 was is 0 now. It's not only P4 that is unknown.
Just listen. I'm coming, please. Give me 1 minute. One, two, three, 7, 8. Supposed to be there. Sorry. We are using this now. We want to get P1, P2, P3, P7, P8. Now, concerning the question that Mayowa asked, can you still hear me?
Yes, sir.
This one is the load applied at that fixed point. Eh? This is the load matrix. That is, if there is any load, external load applied at that fixed point, that is this one. But now, at that fixed point, Gogo, assume we are analyzing it by other methods. When you analyze, at that fixed end, there's going to be what? There's going to be a reaction, upward reaction. Is that correct?
Yes, sir. Yeah.
There's going to be movement. Are you following?
Yes, sir.
So those ones are the ones we are trying to get now with these remaining parts of the global stiffness matrix. This one is just load applied, as in if there was any load applied at that point, that's the one we are using this formula for. But now we want to get the actual reactions at those points. Then there is a need for us to use this one, and we are going to apply this same global stiffness matrix and the values that we just calculated, D5, D6, D4. So we are going to multiply this one by D5, D6, D4. That will enable us to calculate P1, P2, P3, P7, and P8. Mayowa, is that clear? Because if we are to go by what you are saying now, that means you are telling us that there is no reaction at that fixed end, and there is no movement at that fixed end, which is not so. Is that clear?
Yes, sir.
Johnson,
Continue, sir.
Johnson, please, I'm not understanding. I won't lie to you. Like, I'm taking it so much. Please, we need a break, please.
I don't want us to finish this. This is just the last part of it. Then we take a break.
Okay, this is the last part. Okay.
Then we take a break and come back for thoughts. So, are you following me? P1, P2, P3, P7, P8 will enable us get the reactions and the movements at those fixed joints and also at the pinned joints. You understand? But this is the one due to external loading. External loading. If there is an external loading at the fixed end, which is not possible, that means that what? There will be a value for P1. I mean, yes, P1. There will be a value for P1 there. But now, there is no external loading at that point. But we know, of course, that there's going to be a reaction at the fixed end, and there's going to be a movement at that fixed end. So instead of having to disturb ourselves to go and be calculating by probably other difficult methods, you can just use this formula to get the reaction and the movement at those fixed ends. That's what we are trying to do. You understand? We are trying to get the actual reaction and movement at that point. I don't know if you understand what I'm saying, Mayowa.
Yeah, I'm getting it. So, sorry, Sir Johnson, can I'm confused somewhere. At P4, can you hear me? At P4, there's a reaction there, roller. There's a support there, roller support. So, but there's no load acting on it. So is that why our P4 is 0? Because there's no load on it, Abi?
Yes, external load. There's no external load there.
Okay. Okay, thank you.
So let's move on. P1. So we bring this one now. We rearrange it. P1, P2, P3, P7, P8. So 1, 2, 3, 7, 8. That's the way it is. This is 5, 6, 4, Abi. Please, so
Yes, that's 5, 6, 4. By God's grace, you are following.
1, 2, 3, 7, 8.
Yes.
I mean the fixed forces to PF. Because what we are doing is we are still applying this P equals PF plus KD to get the reactions and the moment. So we are still using 1, 2, 3, 7, 8. Now PF 1, 2, 3, 7, 8. Is there any 1, 2, 3, 7? As in, is that the order? Is it following the order? Are we confused?
PF for 1, 2, 3, 7, 8 is 30,
Yes.
30, 60, 0, 0. That's PF for 1, 2, 3, 7, 8. Yeah. 30, 30, 30, 30, 60, 0, 0. 0, 0. Yes.
plus A. We are using this. So 0.667 minus 0.111, 0.333, 0.000 minus 0.167, 0.33, 0.056. This is plus, Abi. Is this plus 0.167? Hello?
Hello, sir.
Should I continue or we are confused? I'm yet to receive any response. So
Yeah, following. I'm following. You know about that.
We're following. Carry on.
E5, E6. So what we are doing is we first use the known loads to obtain the unknown displacements. But now we are using the now known displacements to get the unknown reactions. Is that clear?
Oh, we want to find each of the forces using the known values for D5, D6,
Yes,
D4.
it's clear.
Okay, I get. Okay, yeah.
This is before we have gotten them, so let's substitute them inside. Don't forget, 1 over E high will be there, 1 over E high to multiply, our D5 was minus 2.3 something divided by E high. So we are bringing the 1 over E high outside, then we cancel E high. Are we following?
Yes, sir. Yes, yes.
Please, I want us to be responding on time so that we can move.
Just following.
Yes, we're following. We're following.
Please continue.
How come? Please, let's respond on time. We don't have so much time again, but I want to finish this.
We are following.
I want to finish the beam and trusses today. So please, let's just respond on time. Wait, are we having a headache? Please don't tell me.
Yeah. Beam and trust is not going to help us. Just now beg, just another story. Maybe during the week, please. This one is already okay for today to digest.
Good. My head is loaded.
Since we have like 20 minutes break, that you go and sleep and come back.
I sleep now.
Ah,
Next
no,
1 hour.
till tomorrow.
The next 1 hour.
Let's just finish this one. Let's just like.
Very sleep.
This is like the other safe.
Very cool.
Oh, and I want us to finish this thing off.
Johnson.
The truss will take like how many minutes? Is it like sharp, like 15 minutes or 10 minutes?
Apart from the derivation, it is very easy. It's just following similar process like this. You understand? And the derivation for force itself, it's going to hang.
Johnson, please, that trust, another time, I beg of you. Just I beg, we are begging, please. Just give us extra time. You cannot do that trust right now because I'm still trying to get what this one is all about, please. I'm so sorry. Just have mercy on us.
Thank you.
But can you solve it some way and send it to the
group? Okay, but
Sir Johnson. Sir
Come
Johnson.
on, see that one seven
Sir
work.
Johnson.
Oh, please,
Sir
please, let's
Johnson.
organize another tutorial, please.
Sir Johnson, please finish the Lord's work in our life. Just finish it, please. Just help us choose another date then.
I think the issue would be if Mr. Johnson will be available to teach us next time. Because the way he's talking like this.
You'll be available in Jesus' name. Who is that person? Pastor Professor Johnson, please, another day for this tutorial. God bless you.
It's very steep. That's what I'm saying. So let's So let's finish this one.
God bless you.
Has he agreed?
Johnson, can't you?
I've not agreed.
Johnson now. Johnson.
I really want to finish this one. You can do it now. If you can do it now, what do you mean? Mayowa, you can do it now. We can finish everything now. But I'm the one doing the major work now.
So, okay, let's finish this first.
Let's finish this one. Okay, so let's do this. D5, D6, D4. Let's encrypt it. So this one is going to be what? Let me just multiply it straight. Please follow me. You know what you are doing is 0 times D5, 0 times D6, 0.33 times D4. You add them together. Of course, 0 will make this one 0. So we have 0.33 times D4. So that's plus 0.33 times D4. What is D4?
Minus
Wait, hold on,
67.96.
Can you go over that again?
What did you say?
Can you please go over that? What you just said about adding three things to multiply by default?
What you do is go like column. Abi? So 0 times this, 0 times this, this times this. You add them together. That will give you one value. One value. You understand? If you remember what we used to do,
Okay, I understand now.
By 3 columns, 1 by 2 times this. How many rows is this? 1 row by 3 columns times 3 rows by 1 column. So it will give us what? 1 by 1. So that means if you multiply this, multiply this, multiply this, and add them together, it's just going to give you an element, just one value. Understand? We are going to have it here. Is this clear? Just normal multiplication of matrix. Please don't stress yourself. Just normal multiplication of matrix. Hey, let's respond.
Please continue.
Yes, sir, we are fine.
Let's do it by ourselves. Let's do it by ourselves. Do it by yourself. I will just write the final answer. Maya, please call out these values again. T5.
Minus 490.34.
D6.
4.47.
Is this correct?
Yes.
Can we still hear me?
Yes, we
Can you hear me?
hear you. Yes.
Yes, we can hear you. Yes. Yes.
Okay, D4. Mayawa, are this correct? Mayawa,
Yeah, I'm with you, sir.
Mayawa, is it correct?
Yeah, yes, sir.
Okay, I'll just write the answer. So. Yes, so that should be the final answer. Do we understand? Hello? Is it the same as what we got?
I just joined, so I can't reply. You guys should reply, I beg.
I did the first two. Is the same?
Yes. Yes. Yeah, you're correct, sir.
We just take a little break now and come back. Distribute mass and SARS. Nobody saying anything.
Your P7. Hello.
Yes.
Your P7. I got 26.7.71.
I think you must be wrong, bro.
It is 0.056 times 490.34.
Yes.
Abi, then minus 0.167 times 4.47.
I thought some people said they got the same. Okay, you use 4.47. All right, that's the reason. I use 4.468. They are still within the same range, so don't bother yourself. Is that clear?
Even with 4.468, sorry to disturb you, it is
No,
26.712.
Johnson, that's
Is it correct?
I got I think it's 22 or 26.71, a bit minus something. Correct. What's your answer? What's your answer, Emmanuel?
26.713.
Yeah, I think this thing is meant to be minus 0.056, not 0.056 from our previous writing.
Oh,
okay.
That's what. Yes, minus. That's what made you. That's why Johnson did not get it. Then the last one, yes, should be minus.
Minus, all right.
Okay, that's mine. Okay.
We're meant to have.
Okay.
We're meant to have 26 points. I'll be 7.
So which one is minus? The one for which one this is minus?
Thanks for that correction. I'll correct it now.
Is it 5.7 that you said is minus? Okay.
Cleaning it already. Yes, I think you are correct. It's correct now, Abi.
Yes, it's correct now. It's correct now. Yeah, but it's correct now.
Thanks. Okay.
But you need to erase that minus at your P7.
Oh, I didn't even correct it. Thank you. Okay. Should we just do the derivation?
I'm sorry, because someone can someone confirm your P8? I'm so sorry, guys. I don't know why I'm getting a different value. I'm so sorry.
What did you get?
So
What did you get?
I don't know. I got 88.36. I don't know. Is anybody having that value? Or maybe I'm wrong. I want to recalculate again, Sha.
Oh, I got minus
80.39.
Okay, thank you. That means I'm wrong. I'll check now. Thank you.
Okay.
So I want to clean the board and write truss. Please, let's just do the derivation. I really want us to finish it. Yes.
Johnson, can you please go over that PPF?
Which one?
Can you go over the PF from the diagram? Can you please go over the PF?
PF.
Yes, I missed that part.
We have left that part a long time ago.
Oh boy.
Let me clean it up. So that's the end for the question. And I think it's one of the test questions. So I don't mean the test question that is going, the test is going to give us. I mean past question. So that is that. Okay.